Swayam Prabha. Digital India. Educated India.
What is the problem here? Let us comment is between which numbers we are finding. 1160, 718, 174, and another number is 316, 258, 250. We are using the same formula A equal to Q1B plus R1. Next B comes here, R1 comes here, like that we are repeating. Finally, the greatest common number is 1078. Anybody has doubt in this? This is also similar thing. I will write into the same thing which is written as an algorithm. Euclidean algorithm, repeated division method, it is converted into an algorithm. We will take a small example I will take, or bigger example I will take. Bigger number or smaller number? Smaller number will be easier for understanding. So I will take smaller number. I take 12 and 8. What answer you expect? What answer you will take? I want to find the greatest combination between 12 and 8. What is the answer? 4. 4 we know the answer. So I work out based on this algorithm. R1 equal to 12. R2 equal to 8. You check whether R2 is greater than 0. While loop I am coming. While R2 is greater than 0. It is satisfying. Quotient equal to Q equal to R1 divided by R2. How much will come? Integer division. 12 divided by 8. What will be the 1? And R equal to R1 minus QR2. How much is QR2? To find QR2 first. Q is how much? 1. R2 is, QR2 is 8. The second line, R equal to R1 minus QR2. R1 is 12. So if I find R equal to R1 minus QR2 equal to R1 is 12 minus 2 is 1 into R2 is 8 equal to 4. Anybody did not understand this step? I am in which step? Inside the while loop I am in which step? R equal to. What is the next step? R1 equal to R2. So R1 equal to, currently R2 is 8. R2 equal to R. R is how much? 4. Now you check while R2 is greater than 0. Is R2 is greater than 0? Yes. So Q equal to R1 divided by R2. How much will come? 2. R equal to R1 minus QR2, that is 8 minus 2 into R2, 0. R1 equal to R2, 4. R2 equal to 0. You check R2 greater than 0. You check the condition R2 greater than 0 or not greater than 0? Not greater than 0. So we are coming down. Which value we are going to return? R1. What is the value of R1 now? 4. So 4 is the greatest common divisor between 12 and 8. Check whether you are able to understand this algorithm. I am running the example. So, if you follow the steps of the algorithm, for these two numbers, 2740 and the 1760, Q, R1, R2, R, if you are going on separating, you see the simulation. First, R1 equal to A, R2 equal to B. So, what will be A and B? R1, R2. R1 is 2740, R2 is 1760. Next step is Q equal to R2 divided by R1 divided by R2. So Q, how much times it will go? Q is equal to R1 divided by R2. One time it is going. What is the remainder? 980. Next time, this 980 is become R2, 1760 is becoming R1, repeating, finally you are getting 20. 20 is the greatest common divisor. It is an example for the algorithm. Now we are extending the Euclidean algorithm to find the multiplicative inverse also, it will be useful. If you follow the Euclidean algorithm in this format, you can check whether multiplicative inverse is there. To find the multiplicative inverse, this format of algorithm. So you see the algorithm, first R1 equal to A, R2 equal to B. We are introducing 4 more variables, S1 equal to 1, S2 equal to 0, P1 equal to 0, P2 equal to 1. With this, if I am proceeding, now I want to find the greatest common divisor between, once again, R1 equal to 12, R2 equal to 8, S1 equal to 1, S2 equal to 0, P1 equal to 0, P1 equal to 1. Now you check whether R2 is greater than 0. R2 is greater than 0, or what is the R2 now? 8. It is greater than 0. Therefore, Q equal to R1 by R2, it is 1. R equal to R1 minus QR2. QR2 will be 1 into R2, 8. R1 is 12. 12 minus 8 is 4. It is like previous algorithm. Next, R2 is assigned to R1. That means R1 equal to 8. R2 is R. So R2 equal to 4. These two we are changing R1 and R2 role. After this, S equal to S minus Q S2. That means 1. S equal to S1. S1 is 1 minus Q S2. S2 is 0. So Q S2 is 0. S1 equal to S2. So previous S2 it is 0. S2 equal to S. So S is assigned to S2. That means 1. T equal to T1 minus T1 is 1. T1 is 1 minus Q T2. Q into T2 is 2 is 1. t equal to t1 minus 0 minus q t2, that is 1, t equal to minus 1. I got this. Next, while R2 is greater than 0, we check whether R2 is greater than 0. Yes. So R2 is greater than 0 means Q equal to R1 divided by R2. Right now R1 is 8 divided by R2, it is 2. R equal to QR2. QR2 means 2R2. 2R2 means R2 is 4, 8. R equal to R1. Right now R1 is 8 minus QR2. Q is 2 into R2, 4. It is 8. Now R1 equal to R2. Right now R2 is 4. R2 equal to R. It is R2 equal to R means what is R0? S equal to S1 minus QS2. QS2. Q is 2, 1, 2. S1 is 0 minus 2, 2. S1 is S1 equal to S2. S2 is 1. S2 equal to S. So S2 equal to minus 2. T equal to QT2, 2 into T2. How much is T2? 1. 1. Q is 2 into 1. T1 is 0. 0 minus 2. Now, greatest common divisor is R1. So, greatest common divisor is right now R1. And inverse. So, this extended Euclidean algorithm, they will use to find the inverse also. I did not take an example, but among this S and T, last two values, one among them will be the inverse. What is becoming S? S equal to S1, S equal to S1, S1 is how much 1, S2 equal to T1, T equal to T1, T1 is how much 0, not this one, okay. So right now, we did not apply the algorithm for finding the inverse, we found only the greatest common divisor, but this algorithm, you can use it to find the inverse also. In this simulation, any doubt? It is another comment, but we are using the built-in function. In Python, even for matrix inversion, when I was giving the lab examination, that matrix inversion 4 by 4 I have given. The people who were writing programming C and Java, they were taking more than 1.5 hours. The people who used Python, they call the built-in function. Before I stopped giving the question paper, they finished. The logic is same. Python, they are using the logic, they are writing the program. For library functions, how the library functions are made. If you are using a library function, we can finish it fast, definitely. When you go to the industry, they will allow you to use the library function. But when the whole project is stuck up, they will call the engineers. And there may be some art students also. They can use the library function without explanation. But you will be put as a leader, team leader, you have to explain why this goes wrong. So you have to take the algorithm again, you have to work out and say that because of this part, it does not have a inverse, therefore this algorithm will not work. So you have to go for another way. That explanation you have to do. So all the engineering students, not only using the library function, they must know how it is working also. If you are an engineer, you will learn this. If you are, which course you are doing now, BTech means you should learn this. Okay. If you are doing BSc, take it good, no problem. Okay. So nowadays in Python, almost everything is built in. Even before that, in Fortran, when in the 80s I was using Fortran, there itself there was a library called NAP library. In that you can find the solution of simultaneous equation, solution of even nth order differential equation, everything. But we were asked to do once again. The reason is, we are putting, I was working for nuclear submarine. After putting into the submarine, if I am calling the library function, purposefully the person who is making the library function, they should have made a bug. Okay, if they make a bug, the submarine starts emitting radiation or if some problem comes, I must be responsible. So the people who are doing engineering, they are responsible for the design also. So we must be knowing how it is working also. And whenever there is a problem, you have to check how it is working. Yeah, sometimes purposefully also the limitations of that built-in functions will be there. For smaller job, built-in functions will be doing fine. For some constraints it may not work. But when we do, yeah, it should be a difference between a driver and the automobile engineer. Driver also will use the car. Automobile also, engineer also will use the car. Who will be efficiently driving? Driver will be efficiently driving. Up to the time problem comes. Okay, when problem comes, automobile engineer is there. So this is the simulation for the same algorithm. You can see this, that will be sufficient. But I have taken a small example I simulated with. Finally, they will return the value of R1, I think, R1, yes, R1. So 7 is the greatest common divisor between 161 and 128. 7 is the greatest common divisor between 161 and 128. Next day also I am going to mathematics only. Field. Okay. In cryptography there will be one algorithm called AES algorithm. In that AES algorithm, they are using a field called Calais field. In the Calais field, they use a polynomial. Using that polynomial only, we are going to choose a key. So choosing the key is very important for the security. For choosing the key, you have to follow that equation. That equation is based on Calais field. So we will understand what is meant by field, group, ring, field, etc. You should have studied in 12th also. Even in BTech also you should have studied in discrete maths. But I will explain once again. So this AES algorithm and the elliptic curve cryptography, both are using finite field only. These two algorithms only most powerful algorithm. In symmetric cryptography, AES algorithm is the powerful one. In public key cryptography, elliptic curve cryptography is the most powerful algorithm. These two algorithms both are using finite field. So, field is a subset of ring and that is a subset of group. So, we will start with the group, then go to ring, then go to field. After that, finite field. You see the structure. The superset is group. The group will be satisfying four properties. First, you have to start with the algebraic structure. A non-empty set G with a binary operator star is said to be a group if it satisfies four axioms: closure property, associative property, inverse existence, and identity existence. These four properties are satisfied means it is called a group. Now, in addition to these four properties, if it is satisfying commutative property also, that is called abelian group. After that, for field, with respect to multiplications, some property, with respect to addition properties, including distributive properties. Distributive properties, A into B plus C equal to AB plus BC. That property also to be satisfied, then it will be field. Then, first, abelian group to ring to commutative ring. Commutative ring means it will be multiplication also will be commutative. Then, integral domain. Integral domain is commutative ring with unity. And the field with unity and inverse also. That will be field. And finite field, it will be satisfying a modulo group. So these are all the algebraic structures that we will be using in cryptography. First, that finite field, alloys field of 2 power n, that is the most important finite field in cryptography. We start from abstract algebra. These are the axioms for group. Can you say the cube roots of unity with respect to multiplication forms a group? You heard about cube roots of unity? Or I will take a simple example. Set of integers with respect to addition will form a group. Set of integers with respect to addition. Will it form a group? Yes. What will be the inverse of plus 5? What is the additive identity? 0. So it forms a group. With respect to multiplication, will it form a group? Set of integers? No. What is the multiplicative inverse of 5? 1 by 5. Is it available in set of integers? No. So it is not a group. Similarly, in real numbers, it can form a group with respect to addition with 0. With respect to multiplication, other than 0, if you take all the floating point numbers, it will form a group. And cube roots of unity with respect to multiplication, it can form a group. Everything you can do with the composition table itself. For example, if I am drawing the composition table, you multiply 1 into 1, 1. 1 into W, 1 into W would be W. 1 into omega square, omega square. Omega into 1, omega. Omega into omega, omega square. Omega into omega square, omega cube will be equal to 1. omega square into 1, omega square into omega 1, omega square into omega square, omega. Since it is omega cube into omega cube is 1. I have formed the composition table. From the composition table, the multiplication of any two members is belonging to the same group. That means it is satisfying the same set. Therefore, it is satisfying the closure property. Next, the associative property. To take 1 into omega square, it will be equivalent to omega cube, that is equal to 1. So, associative property, if you change the bracket or the order of multiplication, it is going to be the same thing. So, it is associative. What is the identity element? If you multiply with something, you will get the same thing. 1 is the identity element. What is the inverse of omega? Omega into something gives 1. 1 by omega is equal to omega square. The reason is omega into omega square equal to 1. That means the inverse of omega is omega square. The inverse of omega square is omega. Therefore, inverse also exists. Identity exists, inverse exists, closure property satisfied, associative property satisfied, therefore it is equal. You see the axioms, 4 axioms: closure property, associative property, identity element, inverse. These 4 properties are satisfied. It is closed. Will it satisfy commutative property also? You know what is commutative property? A star B equal to B star A. So multiplication 1 into W equal to W into 1, or W into W square equal to W square into W. All are satisfied. Therefore, it is an abelian group. A group, order of a group. If a group has finite number of elements, it is called a finite group. If a group has infinite number of elements, it is an infinite group. So I have shown one group with cube roots of unity. It is finite group or infinite group. How many elements are there with that? 1 omega square. How many elements are there? Only 3 elements are there. So, order of the group is 3. It is a finite group. To take the set of integers with respect to addition, it forms a group. So, it is an example of infinite group. You see the definitions here. If a group has finite number of elements, it is referred to as a finite group. And the order of the group is equal to the order of elements. Otherwise, the group is called infinite group. If I put addition modulo 5, okay, addition modulo 5, if I form the this one composition table, addition modulo 5. Addition modulo 5 I am taking. I am going to add 0 plus 0, 0 plus 1, 0 plus 2, 3, 4. Here 1, 2, 3, 4, 5 mod 5, 0. Here 2, 3, 4, 0, 1. Here 3, 4, 0, 1, 2. Here 4, 0, 1, 2, 3. group is finite group or infinite group? Will it form a group first of all with respect to addition modulo 5? We can do for multiplication modulo 5 also, but I am doing it for addition modulo 5. What is the identity element? 0. This is the inverse of 5. Sorry, inverse of any element. Let me take 3. What is the inverse of 3? 3 plus something should give 0. So what is the inverse of 3? 3 plus something equal to 0. No, minus 3 is not 2. Minus 3 is equal to 2 only. Minus 3 plus 5. Minus 3 is equal to minus 3 plus 5. It is equivalent to plus 5 also once again. So minus 3 plus 5 is 2, 7, 12, 17, all are equivalent only. So minus 3 is also correct, but it is 2 only. What is the inverse of 4? 1. So we find inverse. So identity element is that, inverse is that, we can prove the associative law, we can closure property is known from the table, therefore it is a group. So addition modulo 5, addition modulo m, addition modulo n, these are all groups. It is a finite group or infinite group? Finite group. What is the order of this group? 5. 5 elements are there. What are the 5 elements? 0, 1, 2, 3, 4. 5 elements are there. So some of the familiar groups are signal has come for lunch. I will be doing only 1 or 2 slides. After that we will break for lunch. You see familiar groups, set of all integer under addition, set of rational numbers under addition, real numbers under addition, complex number under addition, integer modulo n under addition. Suppose you take complex number. Addition of 2 complex numbers will be another complex number or not? Yes, closure property. And suppose we have a plus ib. What is the inverse? Inverse of a plus ib? Minus a minus ib. You add a plus ib with minus a minus ib, what will be getting? 0. What is the identity element? 0 is the identity element. You can write 0 plus 0 I. That is only. So set of all complex numbers under addition forms a group. Multiplication non-zero you have to take. Suppose you take 0 also. For example, 5 1 by 5 you can take. Minus 7 1 by minus 7 you can take. 0 0 by 0 is 1. So that is a non-zero. Cyclic group means there will be a generator. For example, for 5 is a generator means 5 power 1, 5 power 2, 5 power 3. By that we have to go on. When modulo 5 it is there, 5 power 1 modulo 5 will be how much? 5 mod 5, 0. 5 square mod 5, 0 like that will come. So, the modulo also, the powers, inverse will be there, not be there. Two questions are there. This is an example of a group for multiplication. Multiplication modulo 5. I did not take 0. From where I have started? 1. 5, 5. Take 5 and 5. Sorry, 4 and 4. How much is coming? 4 4s are 16, odd by 1. So the last line you are putting 1. This is multiplication method 8. This is a cipher called affine cipher. In this, suppose you are given an X. X is the plain text. You will be getting Y as a ciphertext. Here there will be two components for the key, A and B. Ax plus B is the algorithm. So A is the component of the key, B is the component of the key. You have to find both A and B to know the key. Suppose you are given some X. X equal to 4. Y will be known if you know A and B. Suppose we are giving some A and some B, you can find Y value. But if you are knowing only hypertext values, you want to know the plain text value, you have to solve the equation. 22 and 7 are the hypertext values, Y values. You don't know the X value. To find the X value, you have to solve the equation. Solve the equation, first subtracting equation 2 from 1 and getting minus 15A equal to 15 mod 26. This 15 equal to 11. Minus 15 equal to 11. Minus 15, I am putting minus 15A equal to 11A. How it is 11A? Mod 26 value. So minus 15 is equivalent to 11. That way, if you put 11A equal to 15 mod, that means 11 inverse you have to find. Now 11 inverse in some way, if you find 11 inverse into 15 equal to 26, and 11 inverse if you find it is 19. I told you how to find the inverse. 11 inverse how to find in mod 26 is 11 into something equal to 1 mod 26. By that if you find 11 into 19, if you take how much it is coming? 11 into 19 is 190, 209, 209 mod 26. If you put 209 mod 26 would be 19. So once you know 19, A equal to one value if you know, then you can substitute in the other value 19 mod 26 equal to 25. Once you know the inverse, A equal to 19 into 15 mod 26 equal to 285 mod 26, that is equal to 25. So A equal to 25 you know, B equal to you can find. Once you know A and B, you can find A equal to 25, B equal to 0, you can find X value from Y. In this way you can take it. This cipher is called affine cipher. So the classical cryptography, many algorithms are had, Caesar cipher, Bigneri cipher, Leifer cipher, Hill cipher, affine cipher. 5 algorithm I have. So this 5 algorithm, affine cipher